We're trying to find the area of this shape using Green's theorem. And we've got two equations, y equals 6x squared, y equals 2x. And I've already found the points of intersection. It would be 0, 0, and 1/3 and 2. And we're trying to basically solve this type of equation here, where you kind of can decide whether you're going to be solving the integral using the regular dA method, sort of like setting up, trying to say, okay, well, y goes from 0 to 2, and then sort of setting up the bars that would sort of shift up there. You could do that. Or you could use Green's theorem and take this approach here. And so we're going to practice doing this one. So the best way to set these up is to parameterize this. So what we're going to want to do is you're going to want to do two line integrals. You're going to integrate this direction on this line, and for all of these little integrals that look like this, you have to go counterclockwise. I'll put that right here. So this thing means you're going to go counterclockwise. So that's basically you're integrating around like using a line and creating a full circle. That's what that whole, like this is literally a line, a line integral, but you're making a full circle. Okay, so you're making a full circle. You're integrating along the line and completing that circle. Okay, great. So if you do that properly, you're going to get the area. It's kind of crazy. But anyway, let's try this. So in order to parameterize this, there's a couple different ways we can do it, but I'm going to choose parameterize. I'm going to choose this way, where you could say y is equal to f of x, and x is equal to t, and then t is basically going to start from the x naught and go to x of f, or the final f. And so this will make things really easy because, well, we have to set up two line integrals, so we're going to do this twice. The first one is going to be 1/2, and then we're going to set up this integral. So negative y, well, y is equal to this, 6x squared. So we'll say negative 6x squared, keeping in mind that, well, x is equal to t. So you can actually just replace this with a t. And then we're looking for this dx, and dx is dt. Isn't that cool? Okay, we're going to just kind of ignore that because we're going to pull the dt's out later. But then we're going to go to the next one, which is going to be x, and x is t, and then dy. So dy is going to be the derivative of this, which is going to be 12x, and we can replace x with t, so we're going to do that. And of course, at the end, we have the dt. Okay, so hopefully that would work out pretty well, and we can try to simplify this. This would turn out to be a 12t squared minus 6t squared, so we get a 6t squared, and then there's also a 1/2 out here. Keep in mind that the dt goes from x naught to xf, so that would be x naught would be 0, and xf is 1/3. So we're going from 0 to 1/3. Okay, and this is just going to be basically the integral of 3t squared going from 0 to 1/3. And that's going to be the first line integral. But we're not going to stop there. We're going to go on to the next one, and then we're just going to add them up. So the next one starts like this, 1/2, and then you're going to integrate again, but you're starting from here and going to there. So the y component, negative y, is negative 2x, but remember x is t, so negative 2t. Okay, and then there's going to be a dx, but dx is dt. Again, we're going to have that towards the end. So we're just going to add the next component, which is going to be the x, and x is equal to t, so we just put t. And now the dy is going to be 2. So we technically have a 2 somewhere in there. And then this whole thing is going to be dt over here. Now you can try to add these things up. It's going to be 0. So all of that is just going to equal 0. Well, that's nice. So we really only have to solve this integral, and then we're pretty much done. So we're going to say 3t to the third divided by 3. There we go. This is going to cancel out. And, well, you're going to find out the answer is 1/27. So that wasn't too bad. But, yeah, the key is to parameterize and try to identify what's going on with this stuff. It's pretty crazy.